Cristopher David Moore, known as Cris Moore, is an American computer scientist, mathematician, and physicist. He is resident faculty at the Santa Fe Institute, and was formerly a full professor at the University of New Mexico. Biography. Moore did his undergraduate studies at Northwestern University. He earned his Ph.D. in 1991 from Cornell University under the supervision of Philip Holmes. After postdoctoral studies at the Santa Fe Institute, he joined the institute as a research faculty member in 1998, and moved to the University of New Mexico in 2000. In 2007 he became a research professor at the Santa Fe Institute again, while retaining his University of New Mexico affiliation. And in 2008 he was promoted to full professor at UNM. His primary appointment was in the Department of Computer Science, with a joint appointment in the UNM Department of Physics and Astronomy. In 2012, Moore left the University of New Mexico and became full-time resident faculty at the Santa Fe Institute. Moore has also served on the Santa Fe, New Mexico City Council from 1994 to 2002, affiliated with the Green Party of New Mexico. Research. In 1993, Moore found a novel solution to the three-body problem, showing that it is possible in Newtonian mechanics for three equal-mass bodies to follow each other around a shared orbit along a figure-8-shaped curve. Moore's results were found through numerical computations, and they were made mathematically rigorous in 2000 by Alan Schencina and Richard Montgomery and shown computationally to be stable by Carl Simo. Later researchers showed that similar solutions to the three-body problem are also possible under general relativity. Einstein's more accurate description of the effects of gravitation on moving bodies. After his original work on the problem, Moore collaborated with Michael Nauenberg to find many complex orbits for systems of more than three bodies, including one system in which 12 bodies trace out the four equatorial cycles of a cube octahedron. In 2001, Moore and J. M. Robson showed that the problem of tiling one polyamino with copies of another is NP-complete. Moore has also been active in the field of network science, with many notable publications in the field. In work with Aaron Clausett, David Kemp, and Dimitris Aklioptis, Moore showed that the appearance of power laws in the degree distribution of networks can be illusory. Network models such as the Erdos RE-acute NYI model, whose degree distribution does not obey a power law, may nevertheless appear to exhibit one when measured using trace root-like tools. In work with Clausett and Mark Newman, Moore developed a probabilistic model of hierarchical clustering for complex networks, and showed that their model predicts clustering robustly in the face of changes to the link structure of the network. Other topics in Moore's research include modeling undecidable problems by physical systems, phase transitions in random instances of the Boolean satisfiability problem, the unlikelihood of success in the search for extraterrestrial intelligence due to the indistinguishability of advanced signaling technologies from random noise, the inability of certain types of quantum algorithm to solve graph isomorphism, and attack-resistant quantum cryptography. In 2013, Moore became the inaugural member of the Zachary Karate Club Awards and Honors. In 2014, Moore was elected as a Fellow of the American Physical Society for his fundamental contributions at the interface between nonlinear physics, statistical physics and computer science, including complex network analysis, phase transitions in NP-complete problems, and the computational complexity of physical simulation. In 2015 he was elected as a Fellow of the American Mathematical Society. Selected publications. Moore, Cristopher. Unpredictability and Undecidability in Dynamical Systems. Physical Review Letters 64. 2354-2357. Bibcode 1990 PHRVL 64.2354 MDOI 10.1103. Physrevlet 64.2354 PMID 10,041,691. Moore, Cristopher. Braids in Classical Dynamics. Physical Review Letters 70. 3675-3679, Bibcode 1993 PHRVL 70.3675 MDOI 10.1103, Physrevlet 70.3675 PMID 10,053,934. Moore, Cristopher. Crutchfield, James P. Quantum Autometer and Quantum Grammars. Theoretical Computer Science 237. 275 to 306, DOI 10.1016, SO304 397500191 1, Mr. 1,756,213. Moore, C. Robson, M. Hard tiling problems with simple tiles, discrete and computational geometry 26. 573 to 590, Arxiv, Math, 003039, DOI 10.1007 per seconds 00454, 001, 0047, 6th Mr. 1,863,810. Acleoptus, D. Moore. The asymptotic order of the random k-sat threshold. Proceedings of the 43rd IEEE Symposium on Foundations of Computer Science, pp. 779 to 788, Arxiv, Cond Mat, 02096222, DOI 10.1109, SFCS 2002.11820003. Lackman, Michael, Newman, E.J. Moore, Cristopher. The Physical Limits of Communication, or Why Any Sufficiently Advanced Technology is Indistinguishable from Noise. American Journal of Physics 72. 1290 to 1293, Arxiv, Cond Mat, 9,907,500, Bibcode 2004 AMJPH 72.1290L, DOI 10.1119 1.1773578. Closet, Aaron, Newman, E.J. Moore, Cristopher. Finding Community Structure in Very Large Networks. Physical Review E70. 066111, Arxiv, Cond Mat, 0408187, Bibcode 2004 PHRVE 70F6111C, DOI 10.1103, Physrev 70.066111. Acleoptus, Demetrius, Closet, Aaron, Kemp, David Moore, Cristopher. On the Bias of Trace Root Sampling, or Power Law Degree Distributions in Regular Graphs. Proceedings of the 37th ACM Symposium on Theory of Computing, pp. 694 to 703, Arxiv, Cond Mat, 050307, DOI 10.1145 1,060,590.1060693. Moore, Cristopher. Russell, Alexander, Snydey, Piotr. On the Impossibility of a Quantum Sieve Algorithm for Graph Isomorphism. Proceedings of the 39th ACM Symposium on Theory of Computing, pp. 536 to 545, DOI 10.1145 1,250,790.1250868. Closet, Aaron, Moore, Cristopher, Newman, E.J. Hierarchical Structure and the Prediction of Missing Links in Networks, Nature 453. 98-101, Arxiv 0811-0484, Bibcode 2008, Nature 453, 98c, DOI 10.1038, Nature 06830. Din, Hang, Moore, Christopher, Russell, Alexander, McKelly-son Niederreiter Cryptosystems that resist quantum Fourier sampling attacks. Advances in Cryptology, Crypto 2011, Lecture Notes in Computer Science, Springer, pp. 761-779, DOI 10.1007, 9783-642-22792, 9_43. Moore, Christopher, Mertens, Stephen, The Nature of Computation, Oxford. Oxford University Press, ISBN 978-0-19-923321-2, Mr. 2,849,868.